Welcome to this Kickstarter session. This is the first lecture in a series of lectures on sets. The language of sets is fundamental in modern mathematics. Just about all mathematical facts or theorems are expressed in terms of sets, relations, and functions. So it is important to be familiar with them. Everything here is very, very easy, but somehow, in my experience, this poses a great barrier to entry to higher mathematics. And also, before we proceed, I want to mention that we will not be going into formal set theory and logic, because I don't know formal set theory and logic. All I know is what is known as naive set theory or the informal approach to set theory, which is more than sufficient to get into higher mathematics. And you don't need anything more than that to even obtain the highest possible degree in maths. So with that preamble, let us start. What is a set? I don't know. I don't think I can properly define a set. And the proper definition will be discussed in a book on formal set theory. And I discourage you from getting into it. Right now, it is enough to just have an informal definition, which is that a set is an unordered collection, quote-unquote collection, of well-defined, whatever that means, objects. So we were trying to define a set, and we have a sentence which has more undefined things than the thing that we were trying to define. But still it hints to something. And the best way to understand what we are trying to say is through examples. So this is a set. So when we talk about a set, we draw curly braces, and the things inside the curly braces are called the objects of the set or the elements of a set. And here, the set here is the the first three natural numbers, right? So this is a set. It's a well-defined collection because it's clear what the elements are. There is no ambiguity about them. And it's unordered, so we will get to this what do we mean by unordered. But let's see another example. So here the set is your first three natural numbers and our first two letters of the English alphabet. So that's the set. And this is another set. So this is the set of all the planets in the solar system. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Pluto was kicked out of this list some years ago. When I was a child, Pluto was included in this list, but now it's not, as far as I know. So there are only 8 entries here. All right. And now here is something that is not a set. So all beautiful planets in the solar system. And this is not a set because beautiful is a subjective experience and hence not well defined. So this adjective of well-definedness is important, right? Because a planet may be beautiful to one and ugly to another. All right. So let's go ahead. So this is the notion of belongingness, and this is basically a defining, or let me not say much about that. So here is the thing. Given a set and an object or element, whatever that means, one can ask if the object or element is a member of the set or belongs to the set. One can ask this question and the answer will always be yes or no. So what do I mean by that? This may seem like some very ambiguous or strange thing to say, but here is what I'm trying to say. Suppose X is some set. For example, you can take this set 1, 2, 3 and A be some object. Now A could be anything. A could be a number, or a letter, a fruit, a planet, just anything, any well-defined object. And now one can ask if A is a member of X, right? And if it is a member of X, then we say is an element of X, or we say A belongs to X, or we say A is in X, or we write this. So for instance, I mean, we will look at examples, but for instance, suppose this is our set X, and 2 is our object, the number 2, then 2 is a member of X, right? 2 is sitting here. So in that case, we say A is an element of X, or A belongs to X, or A is in X, or we use this notation. This is a convenient notation here. This is like an E, kind of like an E, but it's curly. So let me draw that again. It's like this. And if you know LaTeX, this is how you generate that in LaTeX, that symbol. But if you don't know LaTeX, then forget about it. Okay. Oops, sorry about that. What did I do? Yeah. So if A is not a member of X or not an element of X, then we write A and then we slash out this guy and X. So these are just some notations. Rather than saying things in words, when we write a proof, this is very, very convenient, all these things, because every time writing things in words takes a long time and it's tiring. All right, so let's see some examples. So Mercury belongs to the set of all the planets in the solar system, right? Pluto does not belong to the set of all the planets in the solar system, as we commented earlier. And in notation, if you want to use this notation, 1 is an element of this set, 4 is not an element of this set. All right. Here are some standard notations which are used frequently. So this denotes the set of all the natural numbers. So what we do is we first draw an n, and then we draw a vertical line adjacent to that. We just don't write a simple n. This is a special kind of n. And again, in LaTeX, you can use, I think, there are many options, but I think this should generate that, or something looking like that. Okay. This denotes the set of all the integers. So it includes the whole numbers, it includes the number 0 as well as the negative integers. So this is a convenient symbol. This is used to denote the set of all the rational numbers. This is used to denote the set of all the real numbers. Let me draw that again. So it's similarly, you draw an R and then you place a vertical line here. Here you draw a Q and then you kind of cut it a little bit. Okay. So this is the set of all the real numbers, and this is the set of all the complex numbers. Frequently used notations. And now, this is very important, roster and the set builder form. How to express a set, basically. So suppose S be the set of all the even natural numbers. How would we express it? So this is an expression. This is a perfectly fine way to describe the set S, but this is in words. How do we express it in a more succinct fashion in symbols? So there are two options. One is the roster form and the other is the builder form. Rather than defining what is the roster form, what is the builder form, let me just give an example. So in roster form, that thing will be written this way: 2, 4, 6, ... or maybe you can write more, but let me just stop at 6. So this would be the expression in the roster form. So basically in the roster form, you jot down all the elements of the set S the best you can. Since this is an infinite set, you cannot possibly write down all the elements, but you do the best you can. In builder form, you are much more precise. So in builder form, you say, so this is the, one way to write it in builder form. So all those n's, such that first of all, n is a natural number, and 2 divides n. This is one way to write it in builder form. So you are basically saying exactly what are the things that lie in the set S. Those n's, which are first of all natural numbers, and which are even. So you could also write n is even, that is perfectly fine. That is also fine, but I have written it this way. So this is the builder form. Now in the roster form, the problem is you are relying on the reader to interpret this the same way you intend to. So you're basically asking the reader to read your intention. It is not clear that the next number here is 8 and then 10 and so on. It is not clear because, for instance, somebody could look at this and think of something like the Fibonacci series. 6 is the sum of 4 and 2. So maybe he might think that the next number is 6 plus 4. So it's 10 and then 16 and so on. So that's the problem with roster form. It is not precise. Roster form can be precise if S were a finite set. In that case, you can, in principle, write down all the elements of S, and then nobody can question as to the ambiguity of S. But the alternative is the builder form, and this is what we generally use whenever we have an infinite set. This is the way to go. Even if you have a big finite set, suppose you have a set with 100 elements, you're not going to write down all of them. So you use builder form. But having said that, we also frequently use the roster form, and no confusion is caused unless somebody is going to play nasty. Okay, so much about that. Yeah, so another way to write the same thing is the following. This is also the roster form. So we kind of we can club some of it before this symbol. So yeah, I should mention, what is this double dot? This is read as such that. So n such that these two conditions are satisfied. So that is the template of the builder form. You write a symbol and then you just prescribe all the conditions that the symbol satisfies. And it is convenient to, take some of the conditions before the such that. It's completely fine. So you may write n in n. So what I mean, all the natural numbers n such that 2 divides n. This is another way to express the set in builder form. And another point of notation, instead of these 2 dots, one sometimes may use a vertical line also. That is also a notation. Right, so I don't want to fully prescribe everything about the builder form and all that. As you read more and more maths, these things go into the background and you don't have to worry about them. But this is the best I can do right now. We can look at more examples. So suppose S is the set of all the positive integers, or in other words, natural numbers, which are less than 100. So in the roster form, in principle, you can just express all of them, but of course, this is the economical way to do it. And hopefully no one would get confused when you write it, that what you mean is indeed the set of all the natural numbers less than 100. So yeah, I say less than 100, so I can't include 100. I have to stop at 99. Okay, but in builder form, it's much more precise. You say all the natural numbers which are less than 100. Right? That's one way. Or you could say all n such that they are natural numbers and they are less than 100. Both are fine. All right. The set of all the rationals. So we already saw that this is the symbol for the set of all the rationals. But if somebody wants to, express it in a more fundamental way, then you would say all these numbers p by q, where p is some integer, q is some natural number. So this is another way to express the set of all the rationals. Or even better would be all those x, maybe all x's such that x is equal to, or I should say there exist. So let me write there exist p and q, there exists p in z and q in n, such that x equals p by q. This is another way, but if I were to write, I would prefer this. Or I would just write the symbol, because there is already a symbol present, a standard symbol present to denote this. All right. Let me end with some remarks. So a set may contain other sets. That's completely fine. The elements of a set may themselves be sets. For example, you can consider this set, and there may not be any verbal way to capture what exactly this set has. It is what it is. So this is written in the roster form. And since there is no verbal way to capture it, there doesn't seem to be any good builder form for it. Anyway, so that's one example. Repeating an element when describing a set does not change anything. Redundancy is fine. So for instance, 1, 1, 2, 3 is the same thing as that. So repetition is allowed when you're expressing things in a set. And ordering. So we mentioned that a set is an unordered collection of well-defined objects. So this set is same as that set because changing the order doesn't do anything. And two sets are equal if they have precisely the same elements. So this set is not the same as that set because 4 is an element of this guy, but 4 is not an element of this guy. And finally, the empty set deserves a special mention. So empty set is the set which contains no elements. It is a legitimate set. Either this symbol is used or that symbol is used to denote the empty set. And if, it may seem a little bit trippy, but this guy is not the empty set. This is the set which contains the empty set. So it may be a little bit trippy. In fact, some people express it like this. It's okay, but it throws me off when I see that. It's ugly. So yeah, I hope this is the end for this lecture. And we will continue our discussion with sets the next time. As usual, like, comment, share, subscribe. And thank you for listening.